Schematic diagram of the newly discovered planetary system around Ross 508. The green region represents the habitable zone, HZ, where liquid water can exist on the planetary surface, National Institutes of Natural Sciences. Astronomers of the Subaru Strategic Program have discovered a possible super-Earth at a distance of 37 light-years from Earth. The discovery was made with the infrared spectrograph IRD on the Subaru telescope IRD-SSP in Hawaii. NASA Exoplanets tweeted Thursday morning that a super-Earth has been discovered in the habitable zone of its red dwarf star. The exoplanet is about 4 times our planet's mass and has challenged us with a problem it schemes in and out of its star's habitable zone. The planet, named Ross 508b, shows continuous movement in and out of its habitable zone, but still has a chance of holding water on its surface, and as the James Webb Space Telescope starts its operations, it might be a crucial find. The distance from a star at which liquid water could exist on the surfaces of orbiting planets is referred to as the habitable zone. Habitable zones, also called the Goldilocks zones, may have ideal environmental conditions for life to flourish because they are neither overly hot nor too cold. Ross 508b passes through this zone in its orbit around the star. The exoplanet revolves around a star 1/5 the mass of the Sun situated at the inner edge of its habitable zone. The average distance from its central star is 0.05 times the Earth-Sun distance. Ross 508b is the outcome of a renewed emphasis on red dwarf stars, which make up 3/4 of the stars in our galaxy and are abundantly found close to the solar system. Ross 508b is the first successful detection of a super-Earth using only near-infrared spectroscopy. Prior to this, and the detection of low-mass planets such as super-Earths, near-infrared observations alone were not accurate enough, and verification by high-precision line-of-sight velocity measurements in visible light was necessary. This study shows that IRD-SSP alone is capable of detecting planets, and clearly demonstrates the advantage of IRD-SSP in its ability to search with a high precision even for late-type red dwarfs that are too faint to be observed with visible light, says Dr. Hiroki Hirakawa, NAOJ Subaru Telescope, the lead author of the discovery paper. Their limited radiance helps to extend the lifetime of such dwarf stars, but they are considered crucial targets for investigating life in the universe. These stars have a surface temperature below 4,000 degrees Fahrenheit. Currently, Proxima Centauri b is the only other exoplanet orbiting in the habitable zone of the red dwarf star Proxima Centauri, the closest star to the Sun. According to researchers, the planet probably has an elliptical orbit. Its orbital period, or the revolution period, is just 10.8 days, the tweet by NASA Exoplanet said. While the current telescopes cannot directly image the planet due to its closeness to the central star. In the future, it will be one of the targets of life searches by 30-meter-class telescopes, the team said. It has been 14 years since the start of IRD's development. We have continued our development and research with the hope of finding a planet exactly like Ross 508b. We are committed to making new discoveries, Professor Bun-ei Sato, the principal investigator of IRD-SSP said.